Hello everyone. Today we are going to present a dashboard made by me and my project partner Jainam Shah for CSE564's Visualizations final project. This is the poster for our interactive dashboard. It briefly describes the various types of plots contained in the dashboard and uses visual graphics to set the theme for the upcoming dashboard. Our dashboard aims to analyze the road accidents taken place in the United States for the year of 2021. So this is our dashboard. The dashboard is divided into logical sections, each denoting a specific aspects of the analysis. The top right area shows us what happened during the accidents. How did the accidents occur? It describes the specific parameters to each accident that were prevailing at the time the accidents took place. That is real-time data. The left area shows us where the accidents took place. It helps us quickly visualize and get an idea of how the accidents were geographically distributed. Finally, the bottom right area shows us why the accidents took place. They analyze the long-term reasons behind the occurrence of these accidents. Hence, using this dashboard, we answer three main questions which are fundamental to any analysis: how, where, and why. Let us first look at this multidimensional scaling or MDS plot. This plot and this entire top right section denotes the specific parameters existing during each accident. These are the parameters that directly affected the accident. This MDS plot here shows us the correlation between all such variables in the dataset. We have parameters such as value of the temperature at the time of the accident, the humidity of air, the amount of precipitation, the visibility, and so on. Although correlation amongst these values is crucial, each value on its own is also important in analyzing why the accident took place. For example, there might be a specific range of values for humidity in which the number of accidents peaked. Hence, to analyze each value independently, we have also made a line graph. While doing so, we have classified the accidents according to their severity, which ranges from mild, moderate, fatal, and severe. The motivation behind doing this was as follows. According to statistics, the number of traffic accidents per million people in United States is among the highest in the world. This statement causes significant panic. But what is the underlying truth behind the statement? How many accidents are actually causing devastating effects? We believe that it was crucial to classify the accidents according to their severity, since majority of the accidents are just minor accidents which were not resulting in any significant loss in terms of cost or human life. As we can see, most of the accidents belong to the severity of moderate. These are probably cases where the car bumped into some obstacle and timely release of airbags prevented any significant injury to the driver or the passengers. To focus only on the severity of the accidents, we can also press on any category of severity and instantly see roughly how many and which locations such accidents took place.
So that brings us to the next logical checkpoint towards analyzing of the road accidents. Up until now, we have seen how specific uh, parameters that were present at the time of the accident affected the accident, answering the how of the accident took place. Now we are going to move on to why they took place, and we can first for that we first segregate the accidents geographically, as in the bigger picture, the parameters which led to the accident vary locally and hence are dependent on the geographical area. So now to answer the where of the where question, the US map shows us various states where the accidents took place. And to get a better picture, we have divided the we have a pie chart here that shows us the top 10 states where the accident took place, ranking them based on the number of accidents for that state. And by clicking on the state here, we can see in the map directly the points or the accidents in that state. For example, when I clicked on California here, we could see California. And if I click on Florida here, we can see exactly the points in Florida where the accidents took place. And for example, New York here shows New York and so on. And by keeping the pie chart close to the actual map, we can see the effect directly. making it easier. And now that we have segregated the location, the accidents according to the location, we can see the underlying factors for that particular state that might be affecting the accidents. We have considered the following attributes: the education, the gross domestic product, the population density, and the vehicles registered for that state. And in this bar chart, each bar is representative of a state, and the data on the x-axis again is sorted. So, for example, the education, which is in percentage, for example, the percentage of people who have got a bachelor's degree, and it goes from 0 to 100% here, for example. And similarly, the gross domestic product, the population density, and the number of vehicles registered are all sorted. And to see which bar belongs to which state, we can directly click on the state to see its corresponding bar. And so, if we observe this, we can see that the level of education as such does not really have a direct correlation with the number of accidents. We can see that there are even high education levels have low accidents, and low education level has low accidents as well as high accidents are also present in both the sections. And for the gross domestic product, we can see a correlation of an increasing number of accidents for increasing gross domestic product. And we can see for California, which has the highest GDP, it has the highest number of accidents. For population density, we do see sort of accidents increasing as the density increases, but then after a point, it also is decreasing. So there isn't really a correlation there. And last in the last graph, we can see, which is the most obvious one, that as the number of vehicles registered, implying the number of vehicles in that state increase, the number of accidents increases, which makes logical sense. So this dashboard has therefore given us crucial insights for this data and serves as a guideline or a starting point for more in-depth analysis of road accidents by the state or central government to prevent these in the future. For example, uh, here we can observe that for either the temperature or the wind chill, we can see that it increases, the accidents increase till around 65 to 70 degrees. And then after that, it starts decreasing. So we can say that this range here around of 50 to 70 degrees is a range for high accidents, this temperature range. And similarly for humidity, we can observe that again, when humidity percentage is around 60 to 90, it's high, it's the range for high accidents. So maybe this, analyzing each and every parameter like this, we can sort of form a range of parameters for which number of accidents can be very high. And if for a particular location, all these parameters are in this range, maybe we could notify the citizens that they should drive even more carefully as the situation looks like that of high accident. And again, we saw that for population density, one would expect that it has a direct correlation, a high correlation, but from a graph, we could analyze that it doesn't really have a direct correlation or continuously increasing correlation there. So our assumptions can be checked against our visualizations, giving us the importance of visualization. And again, another thing we could also see was that the education also directly does not affect the accidents taking place. Again, suggesting that visualization is very important, analyzation of the actual data instead of just relying on theoretical data, theoretical information and conclusions. So that's our dashboard and our presentation, and and it shows that how visualization can give a lot more insights than just hypothesizing without actual data. Thank you.